Hi, and welcome back to another episode of REDtalks. And in this episode, we're going to be talking about a whole bunch of things, specifically API Lifecycle. Now, Lifecycle, we're not talking about the Lion King here, Kuna Matata and all those kind of things. We're talking about more the technology perspective at the start and the beginning. But first, before we go any further, let's introduce my guest, Joe Pruitt.
How's it going, Nathan?
Going very well, sir. Yeah. Now, you, I think, are the longest-standing employee at F5 Networks that I know. Is that not correct?
I think it is the longest one you know. Yes.
Tell us a little bit. I mean, we could probably spend hours going through the things you've done at F5 over the 19 years.
We're rounding in on 19, yeah.
Wow.
In May.
What's the short version of your 19 years? Well, starting right at the beginning.
Yeah, okay. I'll condense that down to a 30-second blurb. There we go. No, so I joined in '98 to kind of help with our management products, actually to build a management product, because Big IP was just a third-party on a third-party hardware with just a CLI. So I built some GUI work, and out of that, I saw the need for building APIs. Essentially, being able to automate initially through remote GUIs, being able to build remote administration tools on top of our big IPs, starting internally, and then for it kind of build out with our customers. So I built iControl back in 2001, I think was the first release, and that was our Corba and initially Corba, and then our SOAP APIs. So that allowed our customers to have a lot of flexibility early on. We had a bunch of libraries, .NET, Java, Python. So it was a little early for the DevOps thing, but we got in the first maybe 8 years, we were really struggling trying to build this. We have these old slides with got the brick wall down the middle, got the developers over here, and you got the network guys over here. They're lobbing softballs over each other, trying to open tickets. How do we get rid of that bridge and give developers access? Now, early on, and even now, and as you know, there's a struggle. You've got the network guys that have scriptability.
Cultural that's preventing it from happening, really.
Yeah.
They're just two different worlds trying to work together.
They're different knowledge bases, right? So the developer guys know all the agile development and tooling. The infrastructure guys got the scripting piece down. But how do we merge those two together, those skills together, or allow those teams to work together more fluently? So that's kind of where iControl started. With that, we built F-Central. I was one of the founders of that platform to help our customers be able to help themselves and write a community back and forth. So I jumped over to DevCentral and ran that platform for a long time. And about a year ago, switched back into development. About 3 years ago, we introduced our REST interface on Big IP. So we had two kind of major programming stacks. And I came back about a year ago because we had teams developing these REST interfaces. We didn't really have somebody on point to represent the needs of our customers and be an advocate for our customers with regards to our programmability on our stacks. So with that, this last year, we've been working on a couple of initiatives, internal principles, making sure that all the because we have hundreds of developers, all the different product module developers writing their own APIs, essentially. And we got a REST framework team that kind of builds the framework, but there's still a little bit of disconnect between the actual development and design of the APIs and ensuring that they're all consistent across the board. So when a customer goes in and looks at our LTM or some of our security APIs, they behave in similar manners. If there's not learning curve on one versus the other. So we started looking at principles, and with that, we were hearing feedback from our customers that there's been some slipping through the cracks with some breakages and subtle changes in the APIs that developers weren't thinking about because our APIs are kind of auto-built out of our whole platform features. So with that, I think that's kind of what this call is about, to talk about our API lifecycle, and it's really kind of a deprecation model, but a little bit exaggerated deprecation model. So we can kind of get into that, but that's kind of where I'm going at. And we're going now, and it's all around. I'm the advocate for our customers. I've got other architects here who are advocates for our internal development processes and performance and all of that. I'm not as concerned with how the APIs perform. I'm more concerned with if the customers are coming in, that they've got a consistent and reliable experience with our APIs, and then we can let the other architects deal with that. Just want to maintain that separation, so I'm not torn in between making a decision for performance or scalability versus our customers building, when they build solutions, that they can be confident that they'll continue to work for them.
That's becoming. I just don't know how much glare I'm getting. Apologies, audience. It's not just the glare.
You should come up to Seattle. There's no sun out, so you don't have glare here.
It's the California problem and my shiny head working together. So what you're talking about, though, this is becoming increasingly more important because, I mean, for a long time, people have been scripting. I mean, I've had Python scripts on my laptop that I can throw at a big IP because I'm testing something and I need to quickly spin up an environment. I mean, that's fine. And if I upgrade my big IP, I run my script, it doesn't work. It's like, okay, I can quickly look at it and be like, oh, all right. It turns out we may have changed the way that goes in now. We could get away with it back in those days, you know.
It doesn't work when you're deploying 5,000 virtual devices in the cloud. It just doesn't fly like that anymore.
Or when there's a tool chain involved as well, because people don't have the time to then run back through and look at every bit of the tool chain. It's not just one person talking to one device anymore.
Right.
It's many devices. And with these models where it's an entire nuke and peeve, like resetting a segment of a network is literally wipe the config and redeploy a new pattern across that, then you can't have APIs being changed at any point. You need that reliability, that robustness. And that's become increasingly important, especially in the last just, 4 or 5 years, where people are starting to look at, not just automating within the developers, creating their continuous, integration delivery toolchain. Now that they're starting to talk to infrastructure as well, so programmable infrastructure, configuring switches, routers, big IPs, even storage, those types of things. Well, these storage vendors now need to start treating their APIs like software delivery life cycles. Is that basically the gist of kind of what you're...
Yeah, it is, and that's kind of, it started out as let's step back a little bit. With iControl, our SOAP interface, we built that from the beginning on a deprecation model. So there's typically two kind of major ways you deal with API stability over time. One's with building specific versions within your APIs, and the other one is to make it additive, and then as you want to remove features or change them, you mark them deprecated. You give the customer or the user of those APIs adequate time to adjust and learn about it and make changes before that change actually is made. So while this
when you say mark it deprecate, for people not so familiar with APIs, can you just explain how that looks when you do that?
Deprecation is just a warning. So it's included in documentation. For us, it's included in log messages when the APIs are used in auditing process, but it's really a classification for a specific API. So in a traditional version API, each version, it's just a public interface. It's released and it's done. With the deprecation model and the way we've extended that a little bit in our life cycle, we've expanded those classifications to a few more different classifications. So, but with that respect, you go into an API reference or you're using an API, you get notified this API is deprecated. And so with each update of our product releases, we'll include a listing of all of the APIs that were deprecated in the past and in that release. So it will take some work. We're not guaranteeing that if you write a solution, it's going to work 25 years in the future. But we're doing our best. We're still working. It's in the latest release of Big IP was the first release where we've introduced this. And so we're working on a timeline, but typically I like to say 3 major versions. So if we're on 13, it'll work through 15 and into 16. And that's
a long time. Yeah, so the cycles of people's normal upgrade paths. I mean, that's a lot of warning that you need to start thinking about using this differently in the next couple of years.
Yeah, and we're going to have to adjust that a little bit with in F5, we have different products that have different release cycles. Big IPs tends to have a pretty long release cycle, where we're working on shortening that. But we have our products like Big IQ CM and iWorkflow that are on like a 3-month release cycle. So obviously, and again, it's not major versions each release, but 1 year is not enough time. Our customers, when they're developing and they're testing, they're typically 1 or 2 major versions behind in the deployment. Depends on the customer, but large enterprise are. So we also can't say, okay, well, when they're ready to deploy, you've only got 1 major version that we're going to support. So we're figuring that out, and I think it's not set in stone yet, but that's the idea, is that it's all about giving information out to the users and the customers so that they have an expectation when I'm developing this, it's going to work for this at least this long, so that they can plan that in. Versioning, we tried. So we have versioning in our REST APIs now. There's been several issues that we're trying to work around with that, and which has caused some troubles with customers. One is that our versions have not been required. So when a customer, if they don't make use of versions, then they'll suffer these API breakages. So that was kind of the catalyst to moving instead of enhancing our versioning, because whatever we do now, if we start requiring versioning, any script that was written or code that was written that didn't use it would break. So that's a breaking change. So all of this is around making sure that our customers, their solutions work. And like you said, as they're built into tool chains, adding into Ansible scripts or any deployment tools, OpenStack, all of that stuff, you don't necessarily have a developer at hand to do unit testing for their client script automation tools for every release and deployment of upgrade on every piece of software on the back end, especially when they're getting to they've got different versions of Big IP or different versions of third-party hardware, other software solutions. You can't have, okay, GTM upgrades, we got to retest this piece. Oh, and we're upgrading another one that's an LTM, or now we got to do these other set. We don't want to have our customers have to be thinking about that. So, and as you said, automation is it's wedging its way into all forms of automation, whether it's cloud, the templates in Amazon, or whether it's on our own extensibility, our programmability. I think have you done a red talk on our extensibility layers for REST?
No, we're not even.
In the future, look for that. Yeah. But it's allowing to write code that resides on the Big IP. And again, there's upgrades. So our number one goal is to get to a point where our customers can be confident in the time and commitment they put in to developing automation in whatever form, that they're going to have the information they need so that they're not going to get themselves into trouble with something breaking along the way due to a software upgrade. That's really the number one priority for us.
That's cool. So and this is what a lot of people talk about when they say infrastructure as code. I think I already mentioned earlier on that it's treating, I mean, historically, hardware was just, when you bought it, that's what it was. It did what it did. Unboxed it and put it in the rack. Whereas now, though, and this is a big case for F5 networks, where actually, I mean, yes, you do buy hardware from F5, but the majority of F5 developers are writing software.
Yeah.
Software that runs on top. It's not just that we're stamping an ASIC that just does that one feature. Far from it. There is a lot of software that's running on that box and leveraging that hardware. So you can't just treat it like, when I bought it, that's what it's going to be and how it's going to behave, until I replace it 3 to 5 years down the line and get another box. It just doesn't work like that anymore.
No, it doesn't.
You look at configurations and the way that you deploy the configurations, you need to look at them like their software deployment tool chains and treat them like that. And I mean, there's quite a lot of people now are using source control systems to manage their Big IP configs, so they can do a diff between the two configs and just like that, and then they can roll back just by grabbing the link to the previous version of the config and pull it straight out of a Git repo. Like, that's pretty cool. Like, that people are starting to think down that path of, like, instead of just a telnet window that you paste all the CLI commands in and cross your fingers and they worked last time, so they should work this time. Like, we can't treat systems like that when you can, re-image the device and have entirely new functionality, like not small features, but big things come in.
Right. So hopefully we're getting to a point where we're going to enable a lot of those type of features with this process that we're coming up with the API Lifecycle. And maybe I can talk a little bit about what that is beyond deprecation. We talked about deprecation. Yep. You're basically hey, I'm putting a marker on this interface so that you know it may change sometime in the future. It's very common in Java development and Java tools to go into the JRE, the Java libraries, and when you start coding, you'll see, oh, I'll pop up, this is deprecated. Go use this interface instead.
Yeah. Yeah.
So that's really what we're doing. The main reasons we'll mark something as deprecated is one, it needs to be removed. Now, there's going to be some cases where a product feature is gone. It's taken out. Let's say we're licensing some. I'm not saying anything in particular, so I'm not trying to say that features are going to be gone. But if we are licensing a third-party library and that company our license expires and they don't want to renew it, and we have to take the feature off the box, off of our systems. Okay, some things we can provide a stub and we'll do what we can, but those will no longer work. So customers do need to be diligent on that front. But that's true from the product itself. I think in the latest release, we removed Speedy and a couple other protocols. So that's going to happen. Another thing is that, let's say our product inside the schema needs to change. So our APIs need to change. REST is a document model. So you'll get the whole document sent back to you that represents the objects in question. Our products do need to, we get customer requests to make changes in the product to enhance new features, or some of the features don't work for them. So to be able to modify interfaces or change them, we need to, we'll use deprecation for that. So on the old one, we'll mark it deprecated. We'll create a new version instance of it, and then mark that and give notice that, hey, you need to be using this new interface with that as well. So it mainly removing features or changing features are the two kind of key reasons why we'll mark something as deprecated. But extending that, we've really that's why I didn't call it a deprecation model, because we want to go a little bit more, and it's really a classification system, and how giving our developers and our customers an idea of how they use this life cycle of this API over time. So with that, really it's a classification system. So we've introduced early access to our APIs, similar to how you use early access features on the product. A customer has a certain expectation with something that's early access. It's kind of like beta, where it's as close as we think it is to release ready, but we need some customers to look at it and use it and get feedback on it. And that it may be not included in the next release. We're not guaranteeing when early access will become a full-featured aspect of the product, but our APIs have never really had that. So in most of the time, these early access will align with early access features on the product, but sometimes the APIs that are coming out are for a brand new module that's developed. And they're putting it out, but we're not sure if the API usage of that what we are thinking our customers will want to use that and how they'll want to use it is actually what we want to end up with. So early access is the same thing. It's just another classification. Again, you'll get log messages, and with our REST interfaces, we have a special response headers for API status. So you'll get deprecation and early access. We also have some internal flags. So we can, from within the product, if APIs are classified internal, they won't get exposed to the customers, so customers won't accidentally use something that's not been tested or supported. So you work your way up from kind of internal stuff. Then you've got the early access. Early access will move its way to GA. And another aspect with this whole life cycle is a certification process, internal certification, which includes full unit testing, fully documented. There's still some REST interfaces that we have public that don't have full API docs for. We're working on that, but to get this gold standard for our customer, it's got to get compliance certification, make sure it adheres to all our standards, so that consistency isn't. So that if they're using that, it's like another interface that they've used before. Documentation, unit testing. Most of our APIs are unit tested, but it's just for consistency here, just so we can make sure that we've got the full package, and really treating our APIs like a released product feature. It's got a full sign-off checklist and ownership, and that's the whole idea of it. This is our first release, and we're bringing all our developers up to speed on it, and hopefully with this starting out, we'll start the evangelism outside, so to let our customers know about it and what they need to do on their end to make use of it.
That's awesome. So in short, not that I wish to take anything away from all of your excellent explanation, but basically, I mean, the API, if anyone was in any doubt, I mean, rest assured, the API is very much a first-class citizen within F5's development teams and its strategy. I mean, APIs used to be, I'm getting weird light things going on again here now. The APIs, I mean, it's an independent team that's running within the organization even now. Like, so it's not buried underneath a feature or, you know, under the load balancing or under LTM or part of this or part of that. I mean, it's its own organization within the company that's actually there to serve all the other module teams and to educate and to help them along the way with the API Lifecycle. I mean, it's a first-class citizen within the organization, not a tacked-on feature that happens at the end of, you know, a new module being developed or a new module functionality coming out. Is that a fair statement?
No, that's a really fair statement. When we first developed the REST interfaces to get speed to market, we basically tied it off of our TMSH command line. Yeah. So when our developers would, and that is auto-driven from our core schema. So the APIs really were treated kind of as a give me at the end of the release cycle. It's auto-generated and it's ready. We are building up a team that's responsible for when it gets and exposed to our customers. So we're involved from the design reviews and everything for down at each of the feature levels, and then working its way up through the testing and building out our testing team and conformance testing. So we are what we've kind of done with SOAP over the years. We're doubling down here with REST. So starting with our Daytona 13.0 release, this was completed, and I think it's going to take a release or so for everything to really kind of stabilize, but we're making some really good roads. And I think with 13.0, I think there's only one minor breaking change that I know of, and it's with one attribute that was changed, and it kind of had to be because of some intricacies in the product. So the customer should be able to be confident. And again, like you said, we're doubling down. We got a team of folks here that our core goal is ensuring consistency and consumability for our customers. And
for these types of people, this is obviously great to hear, yeah. Because they don't want to be in the details of looking at individual CLI commands, etc. They want to be able to consume a nice REST interface. They want to know, yeah, if I throw these options into the JSON payload with a post, that it's just going to run and tell me that it finished afterwards. I mean, no one wants to be spending time looking at every step of the tool chain, or even to be stuck in a process where that one person knows how to do the automation for that one device, and then another person has to do another one. I mean, the whole point here of the whole DevOps culture is cross teams working together to be able to actually create more automation and more extended tool chains.
I think one of the bigger problems that we're trying to solve is, DevOps, automation, agility. Developers are agile sometimes in their jobs, so lots of jobs jumping around. So you've got these guys that wrote these integration pieces who are no longer in the company, and trying to find that needle in the haystack where something broke is very, very troublesome. Yeah.
So with a good API lifecycle policy strategy within an organization, then obviously we're significantly reducing the likelihood of any of those kind of breakings happening, especially without pre-warning deprecation policies in place and that kind of thing. So safer world for everybody.
Yeah. So I get questions about why don't we double down on versioning and try to fix that.
Can you explain a little bit more? Just I don't think everyone's familiar with the versioning that you were talking about. Can you just tell us
It's basically a different API. So each release would have their own different API. So and with those being, but each release will have all the previous APIs as well. So version 11 will have version 11 API. Version 12 will have version 11 and version 12. Version 13 will have 11, 12, 13. The issue with that, I can talk about the internal issues, but customers don't care about those. But with how fast and how many minor updates we have where we're adding API features, you're going to have like 30 different versions that we have to internally cross-test against. Just with the releases, this isn't a internet-based API that changes every 2 or 3 years. for a third party, like a Twitter service or something, where I don't know, they might be on version 3 or something like that with all the years they've been in line. We have, our product has to change by definition. We need to keep up to date with competition with our competitors. We also need to respond to customer feedback on how things work for them and prioritize those things. So our products we can't just wait. We cannot change our version every 3 releases. Our product is constantly changing, so we need to support that. So for our customers too, if they're having to worry about which version am I using, which minor version or major version, and I think that adds more confusion. It adds a little more work on their front. But in some models, versioning works. I think with Big IP and F5, the way, just with how fast our product changes and adapts over time, that versioning it's troublesome for the customers. And so again, and also because we made some decisions in the first design that did not enforce versioning, that we have a lot of customer tools and client code out there that's not making use of it. So if we switched back to requiring that, then it would break all our customers. So
I just want to explain this a bit for those who are not familiar, because I think a lot of people aren't unaware of how that works. So we'll go explain, like, someone upgrades, let's say they're running 11.61 and then they upgrade to 12. And there is a change that's been made, and it was a documented change. They knew it was coming, but what they wanted to do was continue running the scripts they were already using, because they have a mixed environment maybe. So, there might be some upgraded, some not, and they need the same script to run across everything. So what those people can do is on the version 12, they can put at the end of the REST URI, version equals 11.6.1. And it will run the 11.6.1 API, even though it's on the 12 box. Did I get all that right, Joe?
Yeah, that's how it works.
Yeah, so that's what Joe was meaning when, previous versions are on the box. So it gives that ability. And that is handy for, especially if it's an upgrade process. I mean, what if you've got a couple hundred of these things? How do you then manage that change between I've got some running one, some running the other, and I've got this automation system? Now I'm running 2 automation systems because I've got the upgraded ones and the not yet upgraded ones. And it could take me 9 months to upgrade all of these devices because of all the other outages and dependencies that are going along in the time. So versioning can be extremely useful. But like Joe said, you have to be aware of it, and you have to be implementing that string on the end of it, the query string on the end of the URI. Otherwise, it's just going to run whatever the native one for that version is.
Yeah, and with going with the deprecation model and basically any changes, with a deprecation model, we allow additive changes. So you can add new resources, you can add new attributes to a resource, because that's not going to break any client that's specifically accessing a specific element or relying on the format of that element or that resource in general. So we do allow additive, and that's essentially what the way the deprecation piece works is if you need to change something, well, you create another copy and mark this one as deprecated, or you can add on features. So we can still adapt. It's just you have to make use of this flagging and maintain at least that consistency through a few releases. But for the customer, for what version they're using, it's a different UI. Some version models use like /v1/ something at the beginning. Our design team, I wasn't part of that, but they decided to make it a query string parameter. 6.1, half a dozen the other, same thing. You're passing in saying which version of this object do I want to interface with.
Yeah, no, that makes sense.
But even with versioning, if you're going on $11.6, you won't be able to get any of the new attributes back for the object, right? It's the version of it that it was in 11.6. So if there are additive features, you need to change your version string to a new version, and with that, you got to do a lot of work to figure out what has changed between those two. Because with versioning, there's no guarantee of consistency. They can be 2 completely different objects. We try not to do that, but with versions, the idea is each version is completely unique and separate.
So it's safer to treat them as a workaround for short term than rely on them as something for longevity, really.
Yeah. It'll work if you if you build a solution and you want to stay on Big IP 11.6 forever and go for that, or if you're upgrading Big IP and you never want to make use of any new features on Big IP, theoretically can work. But there were some, like I said, some design decisions that limited us from going down that route, again, for consistency for our users, with not breaking the ones that didn't make use of it before.
So last question,
Yeah.
I think to sort of close this out, and maybe this one's getting a little more philosophical, a little less technical.
Go ahead. Throw it at me.
I'm just intrigued. You mentioned before about what it takes to kind of support API versions over a long time, and we have to treat them very much like software life cycles themselves, and the way we manage them and the impact that they'll have when they change. I mean, how hard is it to maintain support for, like, I think you mentioned 3 major versions? Because when you have features and those features were tested and they work together on one product, the problem is with APIs, you're now relying on other technologies that talk to them and how they talk to them and how protocols evolve, and there's more elements. There's greater combinations of things to kind of look after, isn't there? Like how does that work? Is that really difficult to maintain an API across so many versions for so long?
You mean from a F5 product standpoint, for us internally to support those APIs? It's not as difficult as you think. The way we've designed it, we don't need to get into that, but it's basically just a step-by-step up. It basically works like an upgrade script would work internally on the device. So if you go for 11 or if you go for 12, it'll run through these conversion scripts along the way. So it just depends on where you put yourself in the chain on that. So it's actually probably a little more work for our developers to maintain consistency instead of versioning, because instead of putting differences on each specific part of this chain, you got to stack all the changes that go over time on the final public API that you deprecate on. Yeah. So it's a little more work for F5 to manage the deprecation model and the consistency model versus versioning, but I think it's easier for our customers to deal with the consistency piece versus the versioning. So I'm an advocate for our customers, and I tell the developers, I'm sorry if it's more work for you. This is what we need to do for our customers.
Awesome answer, Joe, and that's why they love you.
That's why the developers hate me sometimes.
Well, again, you're not here just to serve the internal customers, are you? There's a lot of people out there that need to consume this. So yeah, we
have internal customers too, and our TMUI, our GUI, is moving to using our REST. We're in an internal design mode right now too. We kind of relay our architecture to put REST at the very core. So all of our client interfaces, the CLI, the GUI, everything will be using our REST APIs internal. Now, if those things break over time, you're gonna have to change everything up the stack. So I think with that, our internal customers are gonna have more pressure on it too. So
cool. Well, it's good to see the investment for API. I'm obviously a huge fan, because all I do all day is talk about orchestration, automation, those types of things. So a good solid API is very important to me, and the people outside that I talk to as well. So, but Joe, thanks very much for coming and joining us. It's not exactly your first time representing FI publicly, a good 19 years worth of it, in fact. And yeah, glad you're still with us, and I hope we can do another episode in the future when we start evolving, especially the bespoke REST extensibility that you hinted at earlier. We haven't done an episode on that yet. That one will be an interesting one as well.
Yeah, that's going to be some fun stuff. It's going to give our customers what they got with iRules for extending the data plane, extending our control plane. So that's going to be some fun stuff. I think there's some rumblings of things out there already talking about it. So if customers are in that mode to start thinking about those things, look, I think you've done a few posts on them, right? And
yeah, and in fact, before we started recording this episode, I was telling Joe that I got a little bit bored through the Christmas period. I wrote a REST worker that just shares what's going on with the control plane with a Slack channel. Yeah. Like cool things like that. You can tap into the control plane and the management plane and write your own scripts that just intercept or that go collect information from a configuration management database or a meta server and say, you know what, we're going to start pulling information in from other places and build that into workflows. I mean, it's
You no longer need a desktop to run that script, that monitoring script. You run it right on the big IP.
exactly. It's a cool time, but we haven't done that episode just yet. It's coming soon.
Something for everybody to look forward to.
Excellent. Well, thanks very much, Joe.
No worries.
Let you go now. Really appreciate your time. You've been listening to Nathan Pierce. That's me. And Joe Pruitt. That's him. Say goodbye, Joe.
Goodbye, Joe.
Thanks. Thanks for listening.